In this video, we'll be talking about related rates. A quick overview of related rates is that these type of problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. It is also good to keep in mind that the rate of change is usually with respect to time. In our first example, we're going to be dealing with an airplane that is flying closer to a lighthouse, and we have to find the horizontal speed. The first thing that I usually do is draw a picture. Then, I'm going to add labels, and since this is a right triangle, I can use Pythagoras' theorem to get that x is equal to 6. Now, for the problem solving itself, the first thing I do is write out my variables. Since we don't know what dx over dt is, I left it as a question mark. For this problem, we're going to use Pythagoras' theorem, or x squared plus y squared equals z squared. We take the derivative of that to get 2x times dx over dt plus 2y times dy over dt to get is equal to 2z times dz over dt. We can plug everything in now to get 2 times 6 times dx over dt plus 2 times 8 times 0 is equal to 2 times 10 times negative 500. We can simplify this down to 12 times dx over dt is equal to negative 10,000. Divide that to get dx over dt is equal to about negative 833 kilometers per second as our final answer. In our second example, we are dealing with a spherical balloon that is deflating, and we have to find the rate of change of the surface area. I'm going to write out my variables, and since I don't know either dr over dt or dsa over dt, I left it blank. First, I'm going to have to solve for dr dt by using the volume equation. I take the derivative to get dv over dt is equal to 4 over 3 pi 3r squared times dr over dt. Then I plug everything in to get negative 7 is equal to 4 over 3 pi 3 times 3 squared times dr over dt. I can simplify this down to negative 7 is equal to 4 over 3 pi times 3 times 9 times dr over dt. Simplify that to get negative 7 over 36 pi dr over dt, and divide to get negative 7 over 36 pi is equal to dr over dt. Then we use the surface area equation, 4 pi r squared. Take the derivative of that, dsa over dt is equal to 4 pi r squared times dr dt to get the rate of change of the surface area. Now we're going to plug everything in, now that we know dr over dt, to get dsa over dt is equal to 4 pi times 2 times 3 times negative 7 over 36 pi. We can multiply everything out to get dsa over dt is equal to negative 168 pi over 36 pi. And as the pi's cancel out, and we can simplify, we can get that dsa over dt is equal to negative 14 over 3 centimeters squared per minute as our final answer. In our third example, we are dealing with a boat that is being pulled in by a pulley system, and we have to find the speed in which the boat is approaching the dock. Now we're going to write out our picture, and we are given that the sides are 12 and 9, and since this is a triangle, we can use Pythagoras' theorem to get that z is equal to 15. Now, we're going to write out our variables. And since we don't know what dy dt is, and that's what we're solving for, left it as a question mark. Now we're using Pythagoras' theorem again to solve for this. So we use x squared plus y squared equals z squared, take the derivative of that, and plug everything in to get 2 times 9 times 0 plus 2 times 9 times dy over dt is equal to 2 times 15 times negative 2. We can multiply everything out to get 18 dy over dt is equal to negative 60, and divide to get dy over dt is equal to negative 10 over 3 meters per second as our final answer. Now, we use related rates mainly to solve real-world problems. This is mostly used in the science and engineering fields, especially in physics. Thanks for watching.